now let's take case number 3. Okay, now here the object is at C, as you can see in this picture, and the ray of light, let's see, this is the object, and the ray of light comes straight, hits the mirror, go back, because it is parallel to principal axis, it hits the focus and go this way. Now the other ray of light goes from, it goes from here, hits it here, and travels again parallel. It passes through focus, hits it here, and it goes parallel to principal axis. So the image is formed here at this point, which you see by this dash 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 dash, and the image characteristics of the image are: it is formed at C, real and inverted, same size as object. Now because it is same size, m is equal to h1 by ho is equal to -1 because of the size. So we can say linear magnification is equal to -1. Now let's see the case number 4. Object is between C and F. Here is the figure of this. See, between C and F there is a object, and the rays go this way, parallel to principal axis, hits and passes through focus as per the rule number 1, which we covered in the first lecture of this. Okay, the other ray goes through focus and then it becomes parallel to the principal axis, which is again rule number 2. Both the rays rather, they meet at this point, and this point is basically at this point, and we get this image if you join from principal axis to this. Okay, so image in this case is, image is 1 formed beyond C, as you see here, it's beyond C. 2 real and inverted, okay. 3 enlarged, and number 4, the linear magnification is equal to negative, and mod of m is greater than 1. Okay, now you have to remember 2 things. Number 1 is, see, the object is moving. If you see, if we do the analysis, object is moving this way towards the mirror. Okay, now the image is actually moving this way. Okay, now image is getting, see, image earlier it was small, then it was equal size, now bigger. So this is getting, image is getting bigger. Okay, now let's take case number 5, when the object is at as you see in the slide, object at F, right? So here what is happening is, this is F, okay, and this is C. So what we are doing is, at F, the object is placed, it will go this way, parallel, one ray will go parallel, okay, and then what will happen? Parallel to principal axis, and then it will go through F. Okay, it will go through F. Okay, now the second ray, is, it will hit the pole, and it will go parallel to, it will hit the pole, and then it will go parallel to the earlier ray. So I can say this is P, and this is, let's say, A, this is B, okay, it will go this way, this will meet. So these are parallel rays meet at infinity. Okay, now in this case, images one formed at infinity, two real and inverted, three highly magnified, and fourth is, m is equal to negative because it is real, and m would be far greater than 1. Okay, now let's go to case number 6. Case number 6. Now in this, object between f and p. Okay, now here if we see, let's say this is the concave mirror. So the object is somewhere here, and what happens is one ray goes this way and then it passes through focus. So it passes through focus. The second ray actually hits the pole and goes this way. Okay, so this is A, this is B, and sorry, and so this is diverging ray. Now this diverging ray, if you see, it never meets. The reason being, it is diverging, it will never meet, correct? However, if we project it backwards, then it will meet here. At A dash, and this would be B dash. And the image would be upright and positive. Okay, now example of this is shaving mirror. Shaving mirror, it has large, it has large radius, so that the object always falls between focus and mirror to give upright image. Here you can say images formed inside the mirror. To virtual and erect upright. To virtual and erect upright. Third, magnified. So fourth, you can say, m is equal to positive and mod of m is greater than 1. As we know, m is equal to hi by ho. Yeah, here's the image. Yeah. Okay. Here, rays appear to meet. So now guys, let's talk about case number 1 when objects are at infinity, which we skipped earlier, but now we are trying to cover. Now in this case, what is happening? The rays are coming from infinity, right? They are coming from infinity and they are parallel to principal axis. So what is happening is it is getting reflected through focus, okay? Now, as you see here, there are two rays which are coming this way and both are getting reflected to focus. This is pole, okay. So what happens is the image actually is formed here. Now this is a point sized image, but now one thing to remember is, if we have to deduce what type of image it is, then I can say image is 1 formed at F, 2 real and inverted, 3 highly diminished, or we can say point sized. Finally, fourth, we can say m is equal to negative or mod of m is far less than 1.